Rajesh Raman is the chief architect for SignalFx. What does that mean? Well, in this episode, Rajesh and Ian dive into his role and how he focuses on not just the implementation of systems and processes at SignalFx, but also the best strategies and practices that will be needed months down the line. They also go into Rajesh's history at Google and Facebook and discuss cloud technology and the future of the industry. This podcast is sponsored by the Lightning Platform by Salesforce. Salesforce just introduced the Lightning Platform Mobile, the low-code mobile app development platform that empowers anyone to easily build, publish, and manage AI-powered mobile apps for employees and for customers. Find out more at salesforce.com/buildmobileapps.
Welcome to another episode of IT Visionaries. I'm Ian Faison, Chief Content Officer here at mission.org. And in studio, Rajesh, what's going on?
Nothing much. I'm happy to be here. Thank you for having me on the program.
Yeah, we are going to have a real deep dive today into an interesting topic from a really cool new job title that I haven't necessarily heard about a lot. So you're going to tell us what a chief architect does. I mean, I guess I know of a chief architect from the architecture world, but not necessarily from the tech world. And we're going to go super deep into observability, what that means, how it differs from monitoring, and a bunch of other stuff that you're working on at SignalFx. But first, how'd you get into technology?
Oh, that's a great question. I think my earliest memories of working with computers were back in 7th grade. I think my school actually had a programming class, and I took the class. I actually didn't understand anything at the time. But I think a couple of months ago, I know something happened. Things started to click into place. My dad bought me a little computer. And here I'd probably date myself because that computer now sits in the Computer History Museum. But I taught myself programming on that. I had a couple of great friends in school. We continue to be good friends to this day, actually. And we were kind of like in that same programming environment together. We taught each other. We kind of like grew up together. And that kind of like became a passion of mine. I think heading into 8th grade, 9th grade, I think at that time I already knew that I really loved working with computers. And so it's been sort of a continuous journey since then.
And where was that? Where did you grow up?
I grew up in India. This is in Bangalore, India. Today it's the Silicon Valley of India, but at the time it was just a sleepy town.
And what's interesting too is you got your PhD in computer science, which is not always the case I feel like, especially here in the Valley, you have a lot of people who skip undergrad altogether. Why'd you do that?
So at the time when I left India right after high school, and I came here for my undergraduate study. I did it in a liberal arts college called Ohio Wesleyan University, and I really loved the environment there. So they had kind of like a combined department of mathematics and computer science, and I really loved studying the subjects there. And I kind of had like this close relationship with academia. I really enjoyed the studying, the learning, and the environment of university. But in the back of my mind, I always knew that I didn't want to become a professor myself, but I really enjoyed the whole process. And so after my bachelor's degree, I did my master's, and then it was almost a natural continuation into my PhD. I think you were mentioning that a lot of people kind of like skip that process. And I think a lot of that happened with many of my classmates in graduate school as well. They were the .com thing was like heating up a lot at that time. And here I'm probably dating myself, but a lot of them kind of like left early or quit their PhDs early and went on to went on directly to industry. But to me, I felt that if I didn't take that opportunity and finish my PhD, I would probably not come back if I didn't do it right then. So it was there. And in the back of your mind, you're always thinking, is this really something that I'm going to be using, whatever I do over here? Sometimes you get your PhD in a very specific topic and you're wondering whether you're ever going to use that again. But I always had a sense that no knowledge was wasted. And I think in this large scheme of things, I do use sort of a lot of the skills that I learned during that entire process in my day-to-day work as well.
Let's get into what you're working on at SignalFx. And for those of our listeners who also listen to Marketing Trends, one of our other podcasts here at Mission, we had a SignalFx guest on that podcast, Tom, who's actually in studio right now with us.
Surprise.
Surprise, right? So if Tom, if you hear a third voice, piping into your AirPods or whatever you're listening on, That's the voice of Tom, the CMO for SignalFx.
This is a great opportunity for me to get to know Rajesh better, to tell his story like he hasn't necessarily told it to date.
Yeah, no, I mean, this is really fun. And this is actually a teaser because we're going to have someone else from SignalFx on an upcoming episode, but I'll hold that. Maybe we'll tease it at the very end. But tell me what you do as a chief architect and what types of things, what's the scope of responsibilities and what types of things are you working at SignalFx?
Sure. So the chief architect is sort of an interesting role in a company. I guess many companies might fold some of those functions into a CTO-like function, but we are sort of a little bit more deliberate in the way that we approach it at SignalFx. The way I describe it is that the chief architect is a little bit more on a strategic, looking at the technology roadmap, trying to look at what we should be working on 6 months from now or 12 months from now, but kind of like focusing on the actual implementation and the architecture of the system itself. So a complex system like SignalFx, there's a lot of development happening on it all the time. You want to be very conscious that you're making the right kind of technical choices on the things that you make. And while different groups are working, there might be some common themes, or you might notice that there's a relationship between what they're doing, and you want to kind of like bring all those strands together to make a coherent picture of the entire architecture. So you don't want to be accumulating too much technical debt. You want to make sure that development is happening in the right direction, that you're making strategic choices in the choice of technologies and things like that. And I think the chief architect, we basically prioritize some of this work on a longer term thing. We call it sort of the non-functional backlog. So usually product management owns the features and the user visible part of things. But there's a lot of development that you do in terms of care and feeding of your existing system, paying down technical debt, making changes to scalability and stability and all. So all that development also has to be prioritized, and you make sure that you're continuing working on those as well, not just feature development. So we collaborate with like the product management function to make sure that all that work is also getting done in a timely way. So that's kind of like that's one of my functions. The other things that we do, looking on just basically like managing technology and the way technology is understood and used within the organization. So as new engineers come on board, for example, I consider it like part of our job to make sure that they understand what we are building. We get them onboarded, we get them productive. And so education and onboarding is kind of also something that I consider part of our function. So that's kind of like a rough sense of what the chief architect does, especially at SignalFx.
Yeah, it's pretty interesting because I think a lot of, depending on the company, all of that stuff might fall under the CIO, might fall under the CTO. It might be split amongst those. How do you work within the construct of what happens internally versus, it seems like a lot of that is internal versus like customer facing. Are you talking to customers? Is that more of a CTO responsibility? How do you kind of amalgamate all that stuff together?
Yeah, so I do occasionally talk to customers, but I think the way things lie at SignalFx, the CTO handles a lot of the external facing, like representing technology to our customers and that kind of thing. And I'm more of the internal facing function, which is about managing how technology gets built and deployed and stuff like that. But that being said, like, Arjit, who's the CTO, and I are like very close colleagues. We were colleagues at Facebook and we continue to be good friends, and we work together on almost everything. So when representing the architecture or trying to figure out like what the current picture is, like we are always in close contact with each other. But I do some external facing stuff, and Arjit is also definitely engaged on the internal facing things as well. But primarily our focuses are, he is more on the external and me on the internal side.
Yeah, I know it's a unique job title, but I must tell you that the very core of what SignalFx is all about is in fact the architecture of the platform. And so to have somebody whose sole focus is on that architecture continues to, enable us to stay ahead. Because what we've created is, you can probably hear now, there's a bunch of patents that have been awarded, and it's really innovative.
Yeah, and I think that it's a really interesting way of slicing it, because I know that, we talked to a company here in the Valley, Carta, and their CTO says his theory was, I guess their like operational management is that CTO is product side of the house and CIO is internal business functions side of the house. Like pretty much completely separate kind of entities, where one person is building product and one person is focused on essentially like employee engagement of technology, which this is interesting because you have so much external facing with CTO. What a great interview that would be. Maybe in our part 2, we're going to have the CTO on and be able to mirror these 2 episodes up. But I think it's interesting that more companies don't align this way. Why do you think that might be? I mean, you've been at Facebook and at Google, and we'll get into those experiences, but why do you think that this allows for a more streamlined kind of operational and like productivity standpoint way to do business?
Yeah, I mean, I think some of it just has to do with like personality of people and kind of like where they are. Like you can take, for example, if you're making a movie and you have a producer, there are producers who are much more engaged with the way things, get done from a directorial standpoint. For example, they might be engaged more on that, whereas others might kind of like sit back a little bit. So a lot of it has to do with like personality. I think that's part of it. But the other thing is like, as you mentioned, there are things that we do when we represent the product externally that because we are in engineering, sort of very technology heavy focus, that we like to have people who come from the engineering strain to represent that technology to our customers. Whereas in many other companies, it might be something that, the marketing team or the sales team does more of. And so that kind of like coverage pivots the whole spectrum of responsibilities inside SignalFx. So because Arijit like comes with that engineering background and he still takes that on as part of his portfolio to represent it externally, then it leaves like there's this other big function that we have to take care of. And so that kind of falls under the chief architecture, the chief architect, sort of that side of things. In general, I think, so as you mentioned, in some companies, it's like the CTO versus CIO. And in our company, it's basically the CTO versus the chief architect. So, and there are sort of like the CIO is usually often also responsible for business systems that are inside the company. But for the chief architect, like that's not the case in SignalFx. I take care of most like the technology for the product itself, but like business systems like email and like Salesforce and all that kind of stuff are not things that I handle directly.
Let's talk about observability and specifically what you're working on with SignalFx as an operational intelligence platform. Can you share more about what the company does and what are the specific things that you're working on and building?
The way we describe SignalFx to anyone who's kind of like new to us is that we say that we're a cloud environment observability platform, and that has like a few different components to it. So the first thing is like cloud environments. So now everyone is kind of like familiar with what the cloud and what it is. But if you go back like several years, it was somewhat of a relatively new concept. Companies like Facebook and Google had what we now call private clouds, but at the time they were just like massive data centers of very, very large numbers of machines. And you had to kind of like build up the expertise to be able to deploy applications at scale, to understand them, to operate them, to monitor them. And a lot of stuff that we did at SignalFx was kind of like taking those experiences and that knowledge into what we were doing. But now in the age of like public clouds, it's not a problem that only the Googles and the Facebooks of the world face, but like any large application, any large system, any large kind of successful company that has a digital strategy is kind of like facing those same problems or echoes of those same problems at some scale or the other. And so a lot of the lessons that we learned are like broadly applicable to them. So what we've built is an observability platform for people to understand how those applications behave. Are they working as they are intended? Is there any problem? Or if there isn't a problem, like can you still understand what's happening inside the application? Because you would need that level of understanding to fix any problems that might arise in the future. So like monitoring of these applications is sort of by itself not a new concept. Like people have been monitoring systems for as long as systems have been built. I think what's changed is that, cloud environments make these systems much more complicated. They are much larger in scale. They are much wider in scope. And the lifetimes of individual components have been shrinking like anything. It used to be that you could stand up a machine and you'd run it for a few months. Now it's common to stand up a container that runs for a few minutes, or you can like fire up a Lambda or a function that might run for just a few seconds. Monitoring that kind of activity with very high flux is like a complicated problem. And so what we've built is a platform that gives you real-time insight into how these entire environments work. And that insight you apply to making sure that your environments work as intended, but also help understand and give you insight into their operation in general. And so observability is sort of that second part of the problem, which is not only do you know that this thing is working, but you have some insight into what's happening internally so that if something breaks or is not quite working the way you expect, you actually have some insight into what's actually happening inside.
Yeah, I was going to say that it's not only understanding what's happening, but actually now being directly led to where it may be happening.
Yeah.
So that you can actually correct it in the time that it takes you to do so, which these days isn't much because customers expect
instantaneous.
Yeah.
Yeah. What are some of the, types of companies that you all work with, and like, who are the people on the team? Who is this affecting? What are the people's kind of like journey to cloud native, or maybe they're somewhere on that journey, but they don't necessarily know how to get from A to B. What are those customers that you are working with and talking to? What are the issues that they're having?
Sure. So if you look at kind of like our customer base at large, the kinds of companies that we work with actually span the entire length and breadth of the industry. It used to be like, maybe this only affects the very, very large companies who are very sophisticated, who are like web native or so on and so forth.
Do you mean like Fortune 500, or do you mean?
I mean like companies that you would consider them to be native to the web. So maybe they started out like, like Square or Stripe or, companies like that. But in fact, the kinds of companies that we're having traction with like spans the entire industry. So payment tech is of course one of them, but like everyone from apparel manufacturers to like people who are doing payment processing, people who are doing various kinds of reviews of food, like Yelp, for example. And so it's not so much the company itself or which vertical or which industry they are in, but rather their maturity in kind of their organization in this whole digital transformation. So every company now needs sort of a digital transformation that's kind of becoming a given. If you don't have some sort of an online presence, or if you don't have a way of like using an internet strategy, your company's probably doomed in the long run. And so this is a transformation that's happening across the entire like width and breadth of the industry. Now, it might be that in some companies, you have one small division that's trying to drive a digital business forward, whereas in other companies, it might be an initiative that spans the entire organization. But regardless of the scale of which of this transformation is inside the company, it's basically something that continues to grow inside every organization. And so we are finding traction across from very small to very large companies. But if you look at the personas who use SignalFx and who use the product and who are trying to deploy the product, there's this whole DevOps culture, where you have people who are doing operations and you have the developers, and there used to be two different sort of personas, but now that's kind of like merging, where developers are getting very, very close to operations and are in fact most of the time responsible for their own operations. So these developers are sort of like, they ask more sophisticated questions from their applications. They want to understand something at more fundamental levels than people who are just pure operators. And that's where an observability platform like SignalFx really like comes into play, because these engineers say, okay, I'm writing some code, I'm deploying it, but I really need to understand how well is it working, because that's going to inform, for example, what I do next week or next month, in addition to monitoring if something happens. So that category of user is a very key persona in the whole SignalFx ecosystem. The other one is like in larger organizations, you usually have some group that's trying to deploy monitoring as a common strategy or observability as a strategy across the entire organization. And in those organizations, you have the observability group is what we offer as service bureaus. So they are basically almost deploying SignalFx as a service to everybody, or for other engineers in the organization.
Oh, got it. Okay.
And so we offer a bunch of tools for them to manage usage and kind of like hand out understand how the system is being used across the entire user community and so on and so forth. So they are also sort of a key persona in the SignalFx ecosystem, because they represent our company to their internal customers, so to speak. And they need a bunch of tools, and they are sort of our champions as well within those organizations. So if you look across the entire company, you're asking the kinds of users that we have. It's like the DevOps, the engineers and the operations guys, the service bureau type people who are running the observability teams. And then it's across organizations that are kind of either starting in their early in their journey or fairly along their digital transformation journey.
Okay, so what do you think the difference is between observability and monitoring? Or is it the same thing? I mean, is it lexicon, or is this actually something that has some type of important business difference?
So monitoring is a function that has been around as long as people have run systems. When you're operating a service, you always want to know, the very first question you have is like, is it up or is it down?
Yeah.
And monitoring is basically trying to answer that question, is to tell you whether the service is up or down. But that's only the first step, because in this day and age of deploying applications very quickly and doing very rapid pushes, and of having very largely dispersed and very deeply engaged users, when something goes wrong, you also need to know what has gone wrong so that you can very quickly fix it and deploy it. So it's no longer acceptable to have like a 1 hour or 2 hour downtime when something happens. Even a few minutes is way too much. And that's kind of where observability comes in, which is, it's not just sufficient to know whether something's up or down, but you need to know, why has it gone down? What aspect of it is not working? What do you need to do to fix that problem? The practice of observability gives you insight into all the internal state of those systems. So as you see a transaction flowing through, and you might notice that, okay, this aspect of this transaction is where it's broken, and you need to address that. And even in regular operation, even if things aren't broken, and you see the state of how resources are being used or how transactions are flowing through your system, the ability of looking inside your system and understanding how all these different components are working gives you insight into how these applications work. And that's actually great to build up that picture in your mind of what a healthy application looks like. And it also gives you insight into, okay, here are some components that might need work, or here are some components that might become a bottleneck. And that would kind of inform your development going forward, where you could focus on improving those components. So it's not just something that you look at only when things are broken. Like when you use observability as a practice in your organization, you kind of look at your applications like almost all the time, or rather than just when things are broken, which is sort of a more monitoring sort of a way of looking at things.
It's the difference between that real-time problem detection, which is super important, to the predictability part of it. Is how can we like lean ahead and try to figure out what is going to happen and prevent it from going down in the first place.
Yeah, so at SignalFx, for example, the one real fun thing about working at SignalFx is that we are one of our biggest users. We monitor SignalFx using SignalFx. And not only do we just use it for monitoring, but we use it as an observability platform. So any features that we build, for example, we instrument it.
Yeah.
And so when we launch it, we see, okay, how well is it being used? How well is it working relative to the previous implementation? And so by looking at these metrics on an ongoing basis, we say, okay, is this feature that we need to turn on? And once we turn it on, how well is it working? And if it's not working so well, then maybe we should figure out where the problem is. And so we add more instrumentation to figure out where the problem is. And so that kind of like ongoing engagement with your product, rather than just, okay, is it broken or is it not, is sort of a critical thing, because it really helps pace out your development. It really rounds out how your understanding of the whole system.
So who manages those dashboards? Do those come to you?
It's sort of a cross-functional thing, but it does require a little bit of curation on part of the whole engineering team to kind of monitor the main top-level metrics, and then to drill down when issues are happening, to look into the subsystems that might need kind of like some help.
Yeah. So what does this look like in 5 years? Like, where is this going? What is, as people continue these business transformations and their kind of cloud native journey, where do we get to?
So I think there are a few interesting trends that are happening. If you just look at the workloads themselves that have to be monitored, the services that you have to monitor are becoming much more numerous in number. Like I would say, it used to be that you would just use a load balancer in a database, but now if you look at the number of things that Amazon and Google offers, for example, the number of services that you might use, that's growing very large. The lifetime of components continues to shrink. Like I said, from hosts to containers to functions, these things are growing down to number of seconds. And it's also becoming sort of a very diverse, heterogeneous world where it's now normal for most organizations to be multi-cloud. So they might have something in Amazon and Google, and they might have a private cloud and so on and so forth. So the universe of monitorables and observables is kind of like growing very large. If you look at observability as a whole, it used to be a lot of the emphasis was on collecting data, but collecting data has become sort of a commoditized problem. It's not interesting anymore. And right now, where the whole industry is focused on is managing data and giving you insight from that data on dashboarding, anomaly detection, things like that. I think the future of this whole space is going to be around proactively telling you, even before you've defined an anomaly detector yourself, of where a problem might be occurring, to help you sort of do a root cause analysis, help you triage and find out where the issue is. Because if you look at modern systems, they are very large meshes of like services. There are these very large microservice-based architecture, sometimes dozens, sometimes even hundreds or thousands of microservices. So a single transaction might hit many, many thousands of hosts. And trying to localize and find out where the problem is very difficult. And
what would and because you've been working on the microservices APM, I'm curious, like what would those type of microservices be that would, those 1,000, what would a few of those be, and why would that be something that you would need to pinpoint it at, and find the root cause of those different things?
Sure. So I think a great example of visualizing or trying to understand microservices is, imagine that you hit the front page of Amazon.com. So if you look at the front page of Amazon.com, and if you're a Prime member, you might have some promotions for Prime members. That would be something that, let's say, a Prime membership service would be responsible for supplying that content to the homepage. You might also have some products that you previously purchased, and there might be some personalized recommendations based on your specific preferences. That would be another service that was supplying that content to you. You might have an icon that says, okay, you have like 20 items in your shopping cart, and there's another service that's responsible for doing that. And they might have seasonal kind of like promotions. So if you just hitting that front page of Amazon might actually be hitting like a dozen or so microservices that are each responsible for providing some amount of content that's finally assembled into your homepage. Now, the shopping cart service itself, for example, might have to look at your account. It might have to look into a database. It might have to look into a whole bunch of other things to itself give you some information about what's in your shopping cart. Or if you're looking at the one that tells you about your personalized recommendations, it might have to look into, what kinds of movies have you previously watched, or what kinds of items have you previously purchased. So if you look at, you're hitting a dozen microservices, those services themselves are turning around and talking to other services. And the idea is you take a very large, complicated problem like the Amazon homepage, and you break it up into small components that you can distribute to different teams that can build those services independently and deploy them independently. So you don't all have to like walk in, do all your development in lockstep. The advantage of that is it gives your organization a lot of flexibility, both technically and organizationally, to move quickly and to develop quickly. The downside of having that really complicated architecture is that it's very hard to pinpoint when there is a problem, because you're now talking to like dozens, and sometimes like these services start becoming very small. There's a service only responsible for generating unique IDs, for example, or for indexing videos, or you have another service that's responsible for doing inventory tracking or payment processing. And so you very quickly end up with like hundreds or thousands of microservices, as it might be for Amazon. And now if you do a single transaction, and the transaction here might be, I'm viewing the homepage, well, it's going to end up like talking to hundreds or thousands of these microservices, and that are all providing content that needs to be assembled and then shown on the page. Now imagine that this homepage loads slowly for 0.5 of the customers. It takes 3 seconds or 5 seconds for it to load, whereas for everybody else, it loads super fast. Like, how would you identify where the problem is? And that's kind of like the issue that we face with a lot of these microservices APM type use cases, where you're trying to identify like these transaction flows and where it might be slowing down and for whom. So the way SignalFx kind of attacks this problem is that we use a scheme that's similar to many others, which is you try and like follow this flow of this transaction as it goes through the entire system. The challenge here is that the number of transactions can be extremely large for a site like Amazon, but even like for a more modest sites, it can be in the billions of transactions a day, right? So this would be like 1 billion page views, for example. And so because the number of traces can be so large, you usually do some sort of a sampling scheme, which is, hey, I'm not going to capture 100% of it. I'll capture, let's say, 1% of it. And if my sample is good enough, I should get enough insight into what's happening. In most of our competitors' offerings, this choice of whether you're going to capture this trace or not is made at the very beginning. You say, okay, somebody's going to hit this page. Am I going to capture this trace or not? And 1 time out of 100 on average, you'll say yes. And the other 99 times, you'll say no. This approach is called head-based sampling, where you kind of get a uniform random sample across the entire population. The advantage of head-based sampling is that it's easy to implement. All the math that you do on it is statistically valid because it's a random sample. But the disadvantage of this is that it might not actually capture the behavior that you're trying to examine. It might not capture those 0.5% of bad traces that are taking a really long time. So at SignalFx, we have a different strategy where we examine every single trace in the system, but we obviously can't store all that information because there's way too many of them. So instead, what we do is, as we are observing every trace, we build up a data model of what a normal trace looks like and how it normally behaves. And if a trace comes in that's kind of like anomalous with respect to that data model, then we say, okay, this trace is interesting and I'm going to retain it. And the way we make those observations is that we look at every span and say, how long does this span usually take? This particular operation, how long does it usually take? And if it takes longer, if it has taken longer than what it usually does, then we say, okay, there's something wrong with this trace. I'm going to retain it. And so this is sort of the approach that we take. So this is called a tail-based selection, or we call it no sampling, because you're not actually doing a random sample. And what this lets us do is it captures a lot of these anomalous traces, and you help identify these problems much easier because you've actually captured all those anomalous traces, as opposed to saying if it was just random chance whether you happen to capture them or not. It's also very complicated to implement. There's a bunch of data science that we had to do in there to kind of represent what a normal trace looks like and how do we do that efficiently. So that was kind of the challenge, but I think we did a pretty good job on that. And so that's one of our primary differentiators.
Also, there's a great ebook that you all have done that we'll link up in the show notes that kind of looks at some of this sort of stuff for those who want to go deeper on all this and Kubernetes and stuff.
Sure.
As well.
Yep.
Going back to real-time cloud monitoring, how is this evolving? What are you seeing as the evolution of the way that this is done and the way that this can be done moving forward?
Yeah, so actually, as of now, we are the only real-time monitoring system. All the other systems sort of do it with some amount of latency, which is on the order of a few minutes in the common case. When we built SignalFx, we had this sense that real-time insight is a very important component of monitoring these large, complicated applications. You know, I'm a bit of an aviation geek, and my EVP of engineering, Leonid, is also an aviation geek. So we are often fond of making sort of, aviation analogies when we talk about SignalFx and real-time monitoring. But we look at our dashboards as kind of like the instruments that you use to fly an airplane. And it's not much use to those instruments. Like if you make a change, you try and move the stick to the left or right, and it takes you a minute or two to find out what your new heading is. Like it would be an extremely difficult to try and fly an airplane like that. And that's kind of like why real-time systems are critical, which is when you make a change to a system, you would like to see immediately how that system is reacting. That's one aspect of it. The second aspect, and sort of like more critical thing that people can immediately relate to, is that when we can detect a problem within 2 seconds of it happening, it gives your organization a lot of flexibility to handle that situation rather than waiting and finding out that if you find out like 5 or 10 minutes after it happened. By that time, your users have probably already seen it. They're probably already tweeting about it. And in this age of like 3 nines and 4 nines and that kind of availability, every second matters. And so having a real-time system that can let you know as soon as possible is sort of a very critical capability that's becoming sort of almost, I would say, a requirement, and especially in some of these very highly ephemeral environments. If you have a container, for example, that spins up and runs for a few minutes and shuts down, like knowing what it did like 5 minutes after the fact is almost useless.
Yeah.
One of our customers, they do flash sales of apparel. The entire sale lasts like 4 to 5 minutes, but in that 5 minutes, they sell millions of dollars worth of apparel. If it takes you 2 minutes to find out that there's a problem, that has a very concrete cost associated with it. So this real-time nature of monitoring is becoming sort of a critical capability in operating these large sort of environments with very, very high uptime requirements.
Yeah, I was thinking about this the other day. I applied to stay at this campsite. This is like really hard to get campsite. And it opens, it's like, it's Department of Agriculture or whoever runs the website. And basically 10 o'clock Eastern, 7 a.m. Pacific, like on the dot is when it opens up, right? Mm-hmm. And I was thinking about just how much the government specifically will have to engineer these extreme, like we're at the very, very beginning of how complex these sites that we're going to require instantaneous results. We're going to require, as you mentioned, all of this real-time monitoring. And if our, government agencies, I think someone was talking about the other day about how getting the IRS the ability to do online tax returns, right? Mm-hmm. And I think that's being lobbied against and all this sort of stuff. But not to go into that part of it, but this idea that there are so many people that could potentially, so many companies or the government or whoever it is that could be left behind by the fact that if you're not to a second, like how can you let something online that happens exactly at that moment in time? You see, things like flash sales, that was a great example. People selling concert tickets, all of these things where you can get so creative, especially from like, marketing and sales standpoint, getting people in the right place at the right time. And if, everyone was worried, another example, when Game of Thrones launched, everyone was like, of course, Game of Thrones, HBO Now and HBO Go, they're definitely going to crash, right? Because everybody in the world is going to be watching that, everybody in the world, but tens of millions of people are going to be watching this thing. I think it's just such a relevant thing that I think CIOs and CTOs are worried about is how do you stay at the cutting edge? How do you stay in real time when that is the expectation all the time, to be down to the second, that it's always working? And, to your point with the aviation thing, we would have never allowed for that, in aviation, but now with, being off by a minute, you could be missing out on millions of dollars, tens of millions of dollars or whatever.
Yeah, absolutely.
Or just trust. Or just customer trust or anything like that. And you spend all this time to get them to your site, and now they're not going to buy because, your shopping cart has been down for 5 minutes.
Absolutely. And, you'd asked like a couple of seconds ago about like the future of this whole observability space. So I think two critical things that I think are going to happen. So one is that like we are receiving a lot of data. So we receive like, for example, some of our bigger customers, they send us like tens of, almost hundreds of millions of data points that we receive almost on every minute. And there's going to be kind of like increasing amount of data science that we need to do on this almost in real time to be able to extract and like identify like leading indicators of instability and so on and so forth. So I think that's going to be an exciting field where there's going to be a lot more data science being applied on all this data. And the second interesting thing is this, and this is where it ties into the real-time system, is that there's going to be a lot more automation that hangs off of this. And this is a new field that's kind of being spoken about called AI Ops, which is to bring like data science and automation so that many of these sites are almost like self-operated using, real-time analytics, and then using automation so that we can remediate things automatically as issues arise. And, that's only going to be successful if you have a real-time system, because otherwise you're just not going to be able to react in time or make the right kinds of observations or control any system with any amount of fidelity unless you have a real-time system.
All right, let's switch gears here to some of your time, early days at Google, early days at Facebook. You started at Google in 2002. You started at Facebook in 2009. So some really interesting times, early days for those companies. And I think that we've had some folks on the show that have talked about that sort of thing, or about being at those companies specifically in those time frames. And I would love to ask you, what was it like being a software engineer at those companies when being a software engineer was the creme de la creme? You know what I mean? It was like, it was the job to be in the Valley was in those companies, being in that kind of title.
Well, undoubtedly it was an amazing experience. Being at Google at the time that I was in 2002, and, this was still the aftershocks of the whole .com explosion. And so a sentiment in the Valley as a whole was a little bit down in energy. But when you got to Google, like things were just like buzzing. This was really like when the company was really taking off.
What year was this?
So this was 2002.
Or sorry, how big was the company?
So the company was, I think I was employee number 400-ish.
Oh,
something like that, which I thought was very large at the time because I'd worked at a tiny startup prior to that. But who knew it would become what it became? At the time, I joined a group called the Production Group. And looking back, this is kind of like, I would say, a lot of the modern concepts around the DevOps culture were already like kind of like taking root at Google. The production team was responsible for basically all the stuff of actually operating the entire Google system in production. And so it included a bunch of us that were building tools for cluster management. And it also included people who actually carried pagers And they became what became the site reliability engineering team. At the time, the whole site reliability engineering concept wasn't yet there. You had operations guys who carried pagers, and then you had like software engineers. But the production team was sort of like the first, in my experience, like was the first time that we actually saw some of this DevOps culture taking root.
Wow.
Because we also had like engineers who were responsible for the systems that you ran. Those kinds of like values that we had at Google was new to me at the time, and I think it was still relatively new in the industry as a whole. It was a really exciting time for sure. I was, we were routinely working with clusters of, tens of thousands of servers, which now is like it's a laughable amount for Google. But even at that time, I thought like these were among the largest clusters anywhere in the world. And the number of machines was just exploding, day by day, week by week. We were turning up new data centers. It was just an immense amount of activity. And it was a sort of a very fun time. We had in some ways, a relaxed and very positive attitude to work. It was a very enjoyable time at Google for sure.
Well, you were already a PhD of computer science at this point, right?
Yes, I was.
So, I mean, I and the reason why I want to kind of harp on this a little bit is you kind of get a lot of people that kind of give the opposite advice these days. But do you feel like you were really ready for this type of opportunity because you'd spent essentially a decade in school, 9 years in school, like ready to do this thing?
Yeah, actually, that's a great question. At the time that Google was interviewing, they really valued PhDs. That changed a few years later. But at the time, they really gave a lot of value to people who had PhDs. There was a lot of interesting sort of like data science and large system work already being done at Google. And so I guess that's the reason that they wanted that kind of profile. But like, for me, joining Google was not like a huge stretch. So even though I was in academia, I actually worked at the University of Wisconsin where I got my PhD. I got my PhD basically building interesting functionality into a system that has kind of like been a production quality system for a long time. And it continues to be actually like decades later. And so I kind of had my hands dirty building real systems for a while. So to that extent, it wasn't a huge like culture shock or something like that to me. There were other culture shocks for me at Google. So it was, it was very strange for me to rub shoulders with people like Rob Pike and Ken Thompson and Alex Martelli and Guido Van Rossum. And like, these were like, guys that you read about in books who had written books or who had like done like significant things. And it was strange to be like office mates with them. And it always gave me a little bit, you felt a little bit of that imposter syndrome.
Yeah, of course.
At a place like Google, it was like almost a crushing thing. Like you had to learn how to deal with that stuff because, you have to believe that you belong and you have to kind of like get along with the business of doing things. Otherwise it would just like crush you, I suppose.
When you were there through the IPO and then a good while after that, there's you might be able to tell the story better, but that, I forget who it was. I think it was maybe Larry or I don't know, either Larry or Sergey that didn't go to the IPO. They like stayed with the engineers or something like that. It's like, oh, whatever. It's not that big a deal.
Yeah, they were both largely sort of like irreverent people. A lot of the stuff about, Sergey famously always wore athletic shoes. He always wore tennis sneakers, even if he wore a suit or whatever. There are little quips about, things like that, which were really funny. I can tell you a pretty funny story. Even Eric Schmidt was pretty laid back. So we had, at the time, Google's entire office in Mountain View was like one building in 2400 Bayshore.
Yeah.
And like space for engineers to even sit down and do their work was like absolute premium. Because week by week, we would be hiring 10, 20 people, and it was in this one building, and we couldn't find space for any of these engineers. One particular engineer who's been around for a while, Amit Patel, he noticed that Eric Schmidt is always traveling, and his office was always empty. He just moved his desk into Eric Schmidt's office.
Oh my God.
So Eric came back from this trip, and he saw this engineer sitting inside his office. And, to his credit, he was very cool about it. He's like, oh yeah, sure, I'm fine with it.
That is hilarious.
That's some of the crazy things that happened back then. Yeah.
That's great. Did you find that culture, has helped you, be a chief architect? You've been with the company SignalFx for a number of years now and been building, and you all are growing really fast. Did you get something, were there some type of leadership lessons or anything that you kind of gleaned from that experience, or even we can get into the Facebook stuff as well?
Yeah, I think there were definitely things that I learned at Google that I really appreciate. So I mentioned that you rubbed shoulders with all these like famous personalities, but the one thing that really struck me was that none of them really threw their weight around. They never threw their name around. You could go up to them and ask them questions that, in retrospect, you might think is a dumb question or whatever, but they never made you feel that you were bothering them or asking a stupid question. That, and then there was always a culture of arguing ideas on their own merit and not bringing like personality or like, there was no sort of a personal dimension to any of those discussions, which I think I really valued. And I've been very kind of keen on making sure that we continue that culture. I think Facebook was very similar in that sense, that there were a lot of ex-Googlers at Facebook too, from other great companies as well. But there were a lot of similarities in culture in that way. People were very focused on their work, on getting things done, and not so much on egos or throwing titles around. Titles were never a big thing either at Google or Facebook. That's something that we're also pretty keen on at SignalFx.
Yeah, I mean, Tom, when we talked on marketing trends, it's one of the reasons why he was so excited to join was just the founding team and all the leadership team are so proficient and brilliant, but also I think just the way the general culture and everything was really cool to hear. Yeah,
I'm very proud of our team actually. But engineering culture is one of those things. It's like an intangible.
Yeah.
But it's important to maintain the culture and the ethos of an organization. It's sort of the identity of the team, the identity of the organization. And, you have to do some active amount of work to maintain that. Otherwise, you lose your sense of what made SignalFx, or what made Google.
You have a really funny Facebook story. I want you to, I don't know if you can share it for the audience, but I think it's pretty great.
Sure. So I was about 6 or 7 weeks having left Google and having joined Facebook. So at Facebook, they have this great process of onboarding, which they call boot camp.
And this is 2009. So this is
2009.
Like early days.
Yeah, fairly early days at Facebook.
How many employees do you think?
Maybe 1,500-ish, something like that. Which again, at the time, I thought was fairly large, but yeah. So bootcamp usually lasts around 6 weeks. As an engineer, it's a really interesting process because you go and you actually solve actual engineering problems for various teams. They put tasks, usually self-contained, not very large tasks, but actual tasks that are actual engineering work. Instead of writing Mickey Mouse programs, you actually go and add a little feature or fix a little bug or something like that. And in doing that, you kind of learn the whole system and all that kind of stuff. So anyway, I was working my way through boot camp, and I thought I had a fairly successful boot camp. I had finished about 6 weeks of it. And then I received this email, and it came directly from Mark Zuckerberg. Like, I'm kidding you not, like the from is Mark Zuckerberg, and the title of the email is "You are fired."
Oh my gosh.
So at this point, I'm like, oh my God, what the hell did I do? And then I opened the email and I looked at it, and it was kind of written, very concretely on a one-to-one, person-to-person sort of like communication style. But then like none of it was like making any sense to me. But like after a few times of reading it over, I found out that Facebook was of course working on new products and new projects. And somebody had leaked this information about one of those projects to the press. And Mark was obviously very upset about it. He was addressing himself to that particular person, but had sent the email to the company at large because they had not yet identified that single person, and they were, having the security team chase that down. But in the meantime, he was making his displeasure known to the organization at large. But just the way that it came in, that it was like addressed to a single person, it was an interesting few moments till I understood what was happening.
It's such a cold bucket of water on your shoulders when you see that. And I'm sure your heart sinks and you're like, well, I haven't done anything.
Yeah, absolutely. I thought I was doing a pretty good job until then.
Let's get into the lightning round. These questions are fast and easy, just like the lightning platform from Salesforce. You can go to salesforce.com/buildmobileapps to learn more about how you can be fast and easy, like this round of questions. Are you ready?
Sure.
Number 1. What app on your phone are you using that is the most fun?
I would say Slack.
Oh, all right. All right. What do you do for fun on a day-to-day basis? So on the weekends here in the Bay Area?
So I'm learning to play the guitar. I would say that's the most fun thing that I do.
Do you fly?
I do not fly yet.
Working on it?
But I do read a lot about airplanes.
What is your best advice for a first-time chief architect?
For a first-time chief architect, wow, that's a great question. I'd say that your job is to make sure that the right decisions get made, but not necessarily that you have to personally make each and every one of those decisions. You have to make the environment so that people make the right decisions. You have to encourage people to kind of collaborate and make the right decisions rather than forcing your decision on everyone.
Do you have a favorite recent book or podcast that you've read or listened to?
So books-wise, my favorite has to be Patrick O'Brien's Aubrey Maturin series of books. It's actually a series of like 21 books. Wonderful, wonderful stuff. Podcast, I like Dan Carlin's Hardcore History.
Mm-hmm.
It's fantastic stuff.
Do you have a favorite team, sports or otherwise?
Depends on the sport. But yeah, football, I like Green Bay Packers.
Oh, all right.
Formula One, I like Mercedes.
Final question of the lightning round. What is the worst advice that you've gotten in your career?
I haven't gotten a lot of career advice, to be honest. And as a result, I've made lots of mistakes purely on my own merit. But I'd say, so let me just say, so the mistakes that I made is that working with people, networking with people, and understanding what they are doing and making them understand what you're doing is at some level even more important than just writing code. And that's something that like especially engineers don't fully understand, especially when you're fresh out of school. So I would say spend a lot of time on that.
I love it. That's it. That's it for the lightning round and for today's interview. Well, I guess I'll say people, you can find Rajesh on the Twitters at Real Rajesh Raman.
Yep. Actually, do you want a funny story about Facebook about that?
Sure.
Yeah. So Facebook was obviously already had this big platform. I was not on Facebook yet for a really long time. And there was this time where Facebook said, okay, now everybody gets like a handle. You can go grab your handle. And of course, I didn't pay any attention to it.
Yeah.
And then at the time that I interviewed at Facebook, they said, well, you must have a handle because otherwise, that's the way it works. So I searched for Rajesh Raman, Rajesh.Raman, like every single variation of that, and all of it was taken. So I just, and this, I swear, this is way before Donald Trump. Okay. I had never known who the hell Donald Trump was at the time. So I just chose the real Rajesh Raman. I show up to my first day at work at Facebook and they do all your IT provisioning and they give you a laptop and all that kind of stuff. And my internal corporate email address was the real Rajesh Raman at facebook.com. So I'm like, okay, that's not going to cut it. And I had to go get a special exemption where I could use, an email address that would not make me subject to ridicule from everybody else.
And I'm sure once Trump got elected, it was, well, I guess you were gone by then, but.
I was gone by then, but unfortunately my Twitter handle is still realrajeshraman.com. And so that's, I'm sure, gives you the wrong impression to many people, but it is what it is.
Yeah, that's great. Yeah, follow him on Twitter and let us know if there's any way that we can help. And yeah, thanks so much for hanging out today.
Thank you.
Thank you again to our friends at Salesforce. IT Visionaries is brought to you by the Lightning Platform by Salesforce. Salesforce just introduced the Lightning Platform Mobile, the low-code mobile app development platform that empowers anyone to easily build, publish, and manage AI-powered mobile apps for employees and for customers. Find out more at salesforce.com/buildmobileapps.